Hello friends, so here we are with another question on electric field. So the question is that two small conductors carrying charges of 10 and 20 nanocoulombs respectively are separated 0.3 meter apart in air. Find the electric field at a point midway in between them. So it's a very simple question. So first let us draw the diagram. So we have two charges, okay, this. The separation distance is 0.3 meter, okay, the separation distance is 0.3 meter. And we have to find the electric field at a point midway here. So let's call this point A, B, let's call this point P. So this will be 0.15 meter and this one also will be 0.15 meter. B is 20 nanocoulomb, this is 10 nanocoulomb. So now let us imagine that there is a unit positive test charge 1 coulomb, 1 nanocoulomb, let's say, unit positive test charge. We are keeping the same units for simplicity. So it is placed at P. That is the way how we calculate electric field. So electric field, as we all know, is equal to F vector by Q0, where Q0 is the unit positive test charge. So here the electric field intensity due to this 10 nanocoulomb charge at P, as there will be a force of repulsion between this plus 10 nanocoulomb charge and the unit positive test charge, it will be a repelling type. So the electric field vector, it will be something like this. Okay, this is EA vector. And similarly, there will be a force of repulsion between 20 nanocoulomb charge and the unit positive test charge placed at P. Okay, this test charge is placed at P. So that will also be repelling type and it will be directed in this direction. Okay, the electric field vector due to charge 20 nanocoulomb placed at P. So now we have to calculate the values of EB and EA. So EA vector, I am calculating the magnitude only, is equal to 1 by 4 pi epsilon 0 QA by AP whole square, which is equal to 9 into 10 to the power 9, 1 by 4 pi epsilon 0. QA is 10 into 10 to the power minus 9 coulomb, 10 nanocoulomb, by AP square, which is equal to 0.15 whole square. Okay, so that is 10 to the power 9, 10 to the power minus 9 will get cancelled, it will be 90 by 0.15 whole square Newton per coulomb. Let's keep it in this format. Okay, the EA value, let's keep it in this form, it will come in handy. Similarly, the electric field vector magnitude, because of the 20 nanocoulomb charge placed at B, it will be 1 by 4 pi epsilon 0 QB by BP whole square. which is equal to 9 into 10 to the power 9 into QB, which is 20 into 10 to the power minus 9 coulomb. Again BP is 0.15 whole square. So that is equal to 10 to the power 9, 10 to the minus 9 will get cancelled. This will be 180 by 0.15 whole square Newton per coulomb. That is EP. So we have been asked to find the net electric field at P. So here this is the point P, this is EA vector, this is EB vector. See, the length of the vector EB is slightly high because its magnitude is high. EB is of higher magnitude, that's why I have deliberately drawn it of higher length. So the net electric field at point P magnitude wise is equal to EB vector magnitude minus EA vector magnitude. Why? Because EB is of higher magnitude, that's why. So it is 180 by 0.15 whole square minus 90 by 0.15 whole square, which is equal to 90 by 0.15 whole square, which is equal to, it is coming around, let us calculate, 4000 Newton per coulomb, and its direction will be in this, in the direction of EB, in the direction of EB. EB minus EA, it will be in the direction of this. Okay, this one, it will be in the direction of EB vector. Okay, so here it is not it was a very simple question, but we just used the basic concepts related to electric field, the formula, and we calculated the result. Okay, this is the resultant electric field vector EP net. Okay, it is directed in the direction of EB. Hello friends, so here we are with another question on electric field intensity. So the question is that two spheres of charges plus 10 coulomb and plus 40 coulomb are placed 0.12 meter apart in air. Find the position of the point in between them where the net electric field intensity is 0. Okay, so a simple straightforward question, but it's some we have to apply the concept of electric field here. So let us say we have two charges, okay, which are separated. This is, let's say, we call this spot A, call this spot B. This is plus 10 coulomb, this is plus 40 coulomb, and let's say we take a position in between, a random position, let's say this P, which is at a distance of x meter from P to the left hand side from A. So the remaining distance is 0.12 minus x meters from in between P and B. Total is 0.12 meter, which is given. So let us say this position here is P, where the net electric field intensity is equal to 0. Magnitude wise we are taking. Okay, so let us say this is the spot. So we have to determine the value of x. Okay, So here the electric field intensity, because of the charge plus 10 coulomb placed at A at the position P, okay, EAP, that is equal to 1 by 4 pi epsilon 0 QA by AP whole square, which is equal to 1 by 4 pi, let's keep it as 1545 epsilon 0, it is 10 by AP is equal to x, 10 by x square. Okay, this is electric field at position P due to charge placed at A, that is plus 10 coulomb. Then the electric field at position P due to the charge plus 40 coulomb placed at B is, let's call it EBP vector, that is equal to 1 by 4 pi epsilon 0 QB by BP whole square. Let's keep it as 1 by 4 pi epsilon 0, 1 by 4 pi epsilon 0 QB is 40 by 0.12 minus x whole square, because BP is equal to 0.12 minus x. Total distance is 0.12 meter. It is given in the question. The total distance is this much. This is x, remaining 0.12 minus x. So now as the net electric field is 0, okay, net electric field is 0, it means at the point P, EAP vector minus EBP vector, that is equal to 0, because this is the net electric field expression. It is equal to 0 Newton per coulomb. So that implies EAP vector is equal to EBP magnitude. Okay, I have removed the vector sign and the modulus sign, just the magnitude I am taking. That implies the expression of EAP is 1 by 4 pi epsilon 0 10 by x square. That implies 1 by 4 pi epsilon 0 10 by x square is equal to EBP 1 by 4 pi epsilon 0 40 by 0.12 minus x whole square. Okay, 1 by 4 pi epsilon 0, 1 by 4 pi epsilon 0 it's cancelled on both sides. Then 1 by x square is equal to 4 by 0.12 minus x whole square. Taking square root of both sides, root over, we get 1 by x is equal to plus minus 2 by 0.12 minus x. Here we'll only consider the positive sign. Here we'll only consider the positive sign. That implies 1 by x is equal to 2 by 0.12 minus x, because negative distance is it's nothing. It's a wrong concept. There is nothing like negative distance. So we'll take only the positive sign. That implies by applying doing cross multiplication, 2x is equal to 0.12 minus x. That implies 3x is equal to 0.12 meter. That implies x is equal to 0.12 by 3, which is equal to 0.04 meters. So this distance where the net electric field is 0 is 0.04 meter AP. Okay, this distance between the point P and A. So obviously this will be 0.08 meter BP, 0.12 minus x. Okay, so you can express it as the point P is situated 0.04 meter away from the point A or 0.08 meter away from point B towards the left hand side, and this is towards the right hand side. Okay, this is the solution. Basic application of electric field formula.